need to fix the move bug with the character animation, because currently at the moment, and there's an article for this here, by the way, it's called Fixing the Move Bug. So you can find that in the link below, because currently at the moment, when I push the forward on the character, it moves from walking to running and running to walking. And if you look in the animation state, so if I pop that to the side there like that, and then I go back into here, zoom out a little bit so you can see the animator behaving strangely. So like zoom right in on the right bit like that. And then if I go back into here, if I push forward, it's kind of like animating from walk to run, run to walk, and it's not quite right, is it? So we need to fix this. The way we're going to fix this is we're going to add a few new variables to our character. So as I said, it's in this article below, all the code. So if you want to follow that there, you can copy it over. We're going to add some new variables. So the first thing that I've done is I've changed speed to speed magnitude because it makes more sense. It's the thing that we're going to multiply our X and Z movement by to move it faster. And we're going to adjust this depending on whether it's running or walking. So that's one thing that we're going to fix. Another thing we're going to fix as well. We need to create a public float. It's public because we want to change it on runtime to adjust it, called walk speed, and that's 5.0f. That's the speed at which the character should move across the land when he's walking. Then we're also going to do one for run speed, and that's 10.0f. So that's like 10 when he's running. He's going to move a bit faster. And then we've got two variables. So this is the value we adjust speed magnitude by when walking, and this one is comment here. This is the value we adjust speed magnitude by when running. So depending on whether we're running or walking, we're going to move that character faster or slower. Then we've got public float, and then we've got walk speed underscore f, and that walk speed underscore f is the value that we're going to change the parameter to. So remember, in the animator, you've got these parameters, this speed f parameter. When he's walking, we're going to make it so that the walk speed is going to be a higher value than the threshold value, which is actually 0.25. So basically, if you go to the animator and you look at the transition between idle to walk, I wish you could just move like more easily across, but like if I click on that arrow there, you can see that when speed f is greater than 0.25, it goes from idle to walk. When it's greater than 0.5, it goes from walk to run. So we're going to make it 0.26. So he's going to move from idle to walk. And then we're going to create another public float run speed underscore f, and we're going to make that 0.51. So just 1 over that threshold, so it will animate from walking to the running animation. Right, so these are the new variables that we've got, and we're going to use these. So let's put a comment there. This is used to update the animation to walking by going over the threshold. And the same one for that, but we don't really need to make a comment there because you probably understand it. So the next thing we're going to do is we're going to put the code in here. Now we're going to create a function, and this function is going to do all the movement. Why are we creating a function? Because functions are a neat way of organizing your code so you don't have to put so much into the update function, for example. So we're going to set the movement using this function called setMovement. It's got two parameters, float x and float z, sorry. And these are the input values that we get from the horizontal and vertical movement. We're not going to do this animator.setFloat thing here, so I'm going to cut that because I'm going to put that actually in here. although we're going to put that into an if statement in a minute, as you'll see. But we're just going to call set movement. So we're going to call set movement from the update function, passing in X and Z like this. And then this function is going to handle it in a nice, neat way. So what are we going to do in this function? Well, I'll just take that out for now. But we are firstly going to calculate. We're going to calculate the speed based on player input. Right. So how much we press X and Z? We're going to create a new vector, and we're going to get the magnitude of that. We can't use this vector because if we do, there are other things going on here like speed, magnitude, time delta. So we're going to create just a vector based on just X and Z. So, and we're going to call this the magnitude of this vector input magnitude. And it's going to be a new vector based on X and Z. And then we're going to get the magnitude of that. So basically, if this is non-zero, i.e. we are moving, we are going to walk or run. We're going to run only if we're pressing left shift, and we're going to walk if it's the non-zero and we're not pressing shift. So let's deal with the case of if we are pressing shift. So we need to detect using the input library, input.getKey. What we're going to detect, we're going to detect the key code left shift. And so we're combining two conditions here in this if statement. So, and the input magnitude is greater than 0.1 f, so it's non-zero. And if that is the case, then so if we press shift and are moving, we must run. How are we going to make it run? Well, we're going to update this animator like we were doing before, and we're going to set the float. Which float are we going to set? We're going to set the speed underscore f. And what are we going to set that to? We're going to set it to run speed underscore f. Why are we going to set it to run speed underscore f? Because this is going to break the threshold for running. So we're going to move from that walk animation to that run animation. Okay. Else if, and here we're just going to detect if the, so we're going to do the walking bit here. So if the input magnitude is greater than 0.1 f, then we're going to set the animator to walk speed f, right? So this one's going to be running, this one's going to be walking. We're going to walk because it's greater than 0, but we're not pressing shift. The other thing we need to set is this speed magnitude, this thing here, which we're using to multiply our movement vector, so we can actually, how much we move the character across. And what we're going to change speed magnitude by depends on which of these options is true. So we're going to change speed magnitude to run speed here, and we're going to change speed magnitude to walk speed here, like that. And obviously, if we're walking, we want the character to actually move slower across the land. Else, if none of those are true, we're idle. So we're going to set the animator to be 0, the speed to be 0, so it's not moving, and we're going to move from walking to idle. So this is the idle animation, and this here is the walk animation, and here we are updating the speed of the character's movement to a run speed, and here we're updating the speed of the character's movement to a walk speed. Okay, so there we go. And then we're calling that from here. And then if I save that and I go back to here, there's no errors in the code. When I play this now, you will see that if I push forward, it will smoothly animate to walk. And then if I press forward and shift, it will smoothly animate to run. So we've got one error here. Yeah, we're trying to create a vector 2. Why are we creating a vector 2? Because we've only got 2 dimensions, x and z, and we're creating this 2-dimensional vector and then calculating whether it is non-zero or not. So we go back to here and it will refresh the code and we run it again. I think it was running, I've just cancelled it actually. Sometimes it takes a while. Perhaps you've got a faster computer and it'll run quicker on it. So now he's walking, and then because I'm moving at a non-zero speed, and then if I press shift as well, he's going to go from walking to running. I let go of shift, it goes back to walking. Let go of that, goes to idle. So that's how we fix that walking bug, to create that, make that movement smooth. And that